Hello. Um in the previous video, we defined the variables we will need in our analysis. So the variables are defined here. That's what we are going to do, what we are going to use, and we will be making this table. Now we are ready to make this table. We have all the variables in this analysis. As you know, this table shows the average of each group, like average for small group, regular with 8 group. And the average is calculated for 6 different variables: free lunch, race, age, attrition, class size, score. That's step one. In step one, you we calculate the averages for each of the 3 groups. And then in the second step, we will be calculating the p-value. The p-value is a result of a hypothesis testing. So therefore, calculating the p-value is carrying out a hypothesis test. So that is a different command from calculating the mean. So we are going to we are going to use data to calculate those things, implement those things, and I want you to make a table look like this. So let's see. By the way, I have tried it, I have recorded, but I encountered an error, so I am redoing it again. So I think I should do better. We have variables. We are ready, and now I'm not using the command here to show you how we can use this menu option. You can directly choose from the menu. As you can see, there are a number of methods built in this program. So most of the techniques you can learn from the textbook must be built in this program. So even if you do not understand how that works, you don't need even if you don't know the algorithm, still you can implement that. So that's why we are learning program. You cannot understand everything. And by the way, what we are going to do is here. We are going to calculate the average. So average is a kind of summary. So come here. Summary and descriptive statistics and means. This is what we are going to use. I'll click means. And let me erase it. So here, this is the option you will see. And then you need to click the 6 variables that you are calculating the average. So free lunch, white Asian, age, attrition, and then class size, percentile score. If you click that, click the variable from the drop-down menu, you will get these options, these variables. And now if you just click OK, what you are going to get is you are going to get the averages of these variables, but for everyone, average over everyone. But that's not what we want. What we want is the average for each group, for each of the 3 groups. To put that option, to do that, we need to use this option. So group over subpopulations. We are going to group the data into multiple subpopulations. So click this and choose the corresponding variable. Where was that? Class type K, right? So class type K takes 1 or 2 or 3, small, regular, and aid. So automatically the program understands there are 3 different groups, and the program will calculate the average for each value. Right? Then click OK. Then what you will see is this. So by clicking the menu here, that's equivalent to typing this command. So the command we used was mean, and calculate mean for these variables. And we put comma. After comma, there come options you wanna include. So comma option, it was over each value of this variable, right? And then it explains what's the subpopulation. Subpopulation 1, 2, 3 imply these small regular aid. And for each subpopulation, so free lunch, the average of free lunch is calculated for 1, 2, 3. 1, 47%, 47.55%, and 49.8%. Compare these numbers are exactly where these numbers are from, right? You may compare the numbers one to one or after making the table. So like when you submit your answer, do not copy the table like this. Make your own table on Word. You may copy the number, but make it more professionally. Like make a table that look professional, right? That's also a very important skill in your career later. Like when you present something, then your table should look better. So try to do your best. And also, I find that there are some differences. So I mean, the numbers here you obtain here are not exactly the same numbers in the textbook. I do not know why exactly that happens. But my guess is there are two possibilities. First, I updated the code to calculate percentile score, and when I update the code, I may made a mistake, or there were some missing values. So handling the missing values could be another reason, right? For example, if you delete all the missing value observations, then the result will change. Or if I do not delete them, then the numbers will be different. That's another possible reason. But anyhow, the difference is not that significant. It's pretty small difference, so I don't think it's a problem. Anyhow, what you actually, so we calculated the mean like this. So it is a very useful command, and as you can see, group mean you are likely to use that somewhere else in the future, and in that case, you should know how to get help. Help mean. So if you want to use mean, but you don't remember how to use it, then try this. Help mean. Then it tells you the possible options, and here are examples. There are examples below, so you may use those help document to learn or to remind yourself of what you need to do, right? I also use the help document quite often. Like I cannot memorize all the commands. So this is the first tab. So we calculated this part, the first three columns. Now we have to calculate the p-value doing a hypothesis test. By the way, this hypothesis test, remember, a hypothesis test requires a null hypothesis and then test. In this case, the null hypothesis is that the three groups have the same mean for a certain variable, right? For example, this p-value is calculated from the hypothesis that these three groups have the same proportion of free lunch eligible students. That is the hypothesis testing we are doing. So it's comparison of three groups, which is not easy actually. When you compare two groups, that is relatively easy because there is only one equality. You just need to verify the equality. However, when you have three groups, there should be at least two equalities to compare the three groups, right? So you have to check two equalities at the same time, then that's a little more involved. However, we do not need to know the theory because Stata will do that for us. You just need to know where is the command, and if you are using the right command. We are doing hypothesis test, and tests are here. Summary, tables, and tests. So test, and we are going to this multivariate test of means. So it's multivariate test because we are handling three groups. So go there, click that. Let me put this. So this is what you are going to see. So we are testing the means, and we are using multiple sample. And first, the variable that define groups is class type. So this is obvious. And in this case, you have to use only one variable at a time. Otherwise, for example, if you may include two variables at the same time, then what it does here is then it will check 6 comparisons. So free lunch for small group equals free lunch for regular, and white Asian for small group equals white Asian for regular, and then like that. So all the variables are the same for all the groups. So this is not what we want. We have to do it one by one, right? If you if you so this is what we do, and click that. Then this is, so it says test for equality of three groups, three group means, assuming homogeneity. So that's not important. So this is exactly what we are doing. Three group means are the same or not. We are testing. And what we did can be written in this command. Multivariate test about means of the variable free lunch by these groups, by group defined by this variable. And then, okay, so then how can we interpret the table? You do not need to know the techniques. So these are just different techniques how you calculate the test statistic. What we are going to use is the first one. And no matter what you use, as you see, the result is the same. P-value is the same. The last one is the p-value. Probability greater than f is the p-value. So it's f is the f statistic, test statistic, and then probability greater than that is the p-value, and it's 0.09%. I mean 9%. 0.09. That's exactly what you get here, right? So so now, as I said, you have to do it for 6 different variables. Once you do it by clicking that, second time, you may just type here, like this. This is another test for white Asian by the same group, and like same thing. Now p-value is 26%, very, very high. So 26%, exactly, that's what we get. And remember, the null hypothesis is equality. Null hypothesis is all groups are the same. And if p-value is too small, that means the null hypothesis is rejected. In this case, p-value is large, so larger than 5%, then you do not need to reject the equality. Equality is acceptable. Same here, 9%, which is greater than 5% at the standard level, then equality is acceptable. And you can do this for 6 different variables. And again, like you may use help to see what's going on. It's then it explains what is what, and if you are curious about the theory, then it tells you the reference. if you look at this, read this reference, you can better understand if you are willing to do that. Okay, that's how we make the table 1, number 1, 2.2.1. And in the next video, I'm going to show you the other table, how to make the other table. Okay, thank you for watching. See you later.